Good morning, students. We begin with the topic motions of the earth, that is rotation and revolution. So as you can see that there are two types of motion, rotation and revolution. Rotation refers to the spinning of the earth on its axis from west to east once in 24 hours. On the other hand, revolution is the movement of the earth around the sun. Now we are going to study the characteristics of rotation. The first characteristic is that the earth rotates from west to east in 23 hours, 56 minutes and 4.09 seconds. Remember students, you have to learn all these figures. You cannot simply mention that rotation takes place in 24 hours. You have to remember how many hours and how many minutes and how many seconds. The next characteristic is the earth rotates on an inclined axis and it is always tilted in the same direction, that is towards the pole star. I will elaborate on this topic later. The next characteristic is the speed of rotation of the earth at the equator is maximum. It is 1670 kilometers per hour and the distance that it travels is 40,075 kilometers. This speed decreases towards the poles. Next we move on to the topic effects of rotation. This everybody knows. The main effect of rotation is occurrence of day and night, which happens with precession and progression. Now what does precession mean? Precession means that it occurs with an accuracy, and progression means that it happens gradually and not suddenly. And the duration of day and night is not equal at all the places, and this is mainly because of the inclined axis. Then the next effect is sunrise and sunset. These phenomena occur because of the rotation of the earth from west to east. So what happens during the sunrise? When a portion of the earth moves from darkness to sun rays, we call it the sunrise. And when the earth moves, the part of the earth moves away from the sun rays, that is said to be the sunset. The next effect is Coriolis effect. Now what is Coriolis effect? First of all, Coriolis, it's a force which is experienced by an object moving over a rotating body like the earth. Now because of the Coriolis force experienced by the ocean water, we have ocean currents, and ocean currents, they move in the clockwise direction in the northern hemisphere and they move in an anti-clockwise direction in the southern hemisphere. This is because of the Coriolis force. Similarly, even winds, they are deflected to the right in the northern hemisphere and to the left in the southern hemisphere. And this law, which tells us that in which direction the winds are going to be deflected, it is called the Farrell's law. The next effect is that the sun, the moon and the stars, all of them, they appear to move from east to west. It is not the sun or the moon that is moving here. It is the earth that is moving from west to east. It's similar to the effect. It's same as when we are going in a train, and when the train suddenly starts to move, all the objects, stationary objects on the station, they appear to be moving in the opposite direction. So this is called the apparent movement of the sun. Next effect is the centrifugal force. Now this is an apparent outward force which is experienced by any object on the earth due to the high speed of rotation. And because of the high speed of rotation of the earth, there is a bulge in the middle and this flattening at the poles. Next, another effect of rotation is difference in time, and this we have done in the previous chapter called geographic grid. The differences in time is in terms of longitude. For every degree of longitude, the time varies by 4 minutes. Moving on to the next effect, that is, the side of the earth facing the sun gains heat and the other side loses heat. This variation in temperature between the day and night is moderate because of the high speed of rotation. Then rotation and revolution, they together cause seasons and variation in the length of day and night over different places on the earth. This is as far as the effects are concerned. Moving on to the next topic. Our next topic is inclination of the Earth's axis and its significance. First of all, let us try and understand the definition. The axis is the imaginary line passing through the center of the Earth on which it rotates. The Earth's axis is not vertical. It makes an angle of 23.5 degrees with the vertical and 66.5 degrees with the plane of the orbit. Now for this we need to refer to the diagram which is given in your book. It's figure 3.1. Now if you just look at the diagram here, now this is the earth and there is this imaginary line which is passing through the center. This imaginary line which passes through the center and it is inclined to the plane of the orbit. This line here is the inclined axis, and on the opposite side of the axis here lies the North Pole and here lies the South Pole. Now this imaginary line, this axis, is making an angle of 66.5 degrees with the plane of the orbit, and it is making an angle of 23.5 degrees with the vertical. Now what is this plane of the orbit? Now you can see this line here. Now this line is passing through the center of the sun as well as the earth, as well as the earth's orbit. This is called the plane of the orbit. The orbit that the earth takes around the path that the earth takes around the sun, that is the orbit. And this is the plane of the orbit. In the plane of the orbit, it passes through the center of the sun as well as the center of the earth. Now this inclination of the earth's axis has some important contributions here, and it's responsible for many phenomena. Before that, we need to understand another term, that is circle of illumination. Now what is circle of illumination? It is the traveling boundary that divides daylight and darkness. Now what do I mean by this? If I draw a circle here, let us say this is the earth, and if I draw the inclined axis, and let us say this is the sun. From here the sun rays are coming. So this area is going to be completely shaded. This area. And this is going to be a completely lit up area. So this traveling circle, this traveling boundary that divides the daylight from darkness is the circle of illumination. So this is the circle of illumination. Now coming to another topic here, that what if the earth had a vertical axis and not an inclined axis? What would happen then? Now I'm showing a vertical axis here. You see this is the earth, and let us say this is the plane of the orbit, and now here the earth has a vertical axis. Now if this happens, what will happen? We will have equal days and equal nights. That means the duration of day and night everywhere would be the same. Next, all places would have the same temperature throughout the year. There wouldn't be any temperature change in the places throughout the year. And third, there would also be no seasons. So inclination of the earth's axis along with revolution is responsible for the cycle of seasons. Now let us understand how the duration of day and night varies with the inclination of the earth's axis. Now here we have a diagram where we show As you can see here, this line here, this is the circle of illumination. Now this is the side which is lit up and this is the side which is dark. As you can see here, they have shown the inclined axis of the earth. Now if you view these points here, I'm taking the camera very close to the diagram. You can see these points here. It's point C at the equator and this is C dash point at the equator. This is point B and this is point D. Now let's consider point C, and if you consider this OC distance is equal to the OC dash distance. What does this mean? This means the duration of day is equal to the duration of night. Now this point C will reach the C dash point after 12 hours when rotation occurs. But here the duration of daylight is equal to the duration of night. Now this is the case with the equator. On equator, duration of day and duration of night is equal. At the Tropic of Cancer, here what is happening is that this point B and this point X, this length, BX length is more than the B dash X length. What does this show? This shows that the duration of daylight is longer than the duration of night. And if you consider the Arctic Circle, let's say this is the Arctic Circle, the A point here. So here if you see this A dash A, this is completely lit up. That means this at this latitude, during this time, there is going to be, the duration of day is going to be 24 hours. And at the same time, if we consider the Antarctic Circle, what do we see here? We see that the Antarctic Circle is in complete darkness. Here the duration of night is very long. It is 24 hours. So this inclination, the main effect of inclination of the Earth's axis is that duration of daylight and night is not the same. It is different. It is not equal at all places. The next effect is that in the course of Earth's movement around the Sun, the North Pole remains inclined towards the Sun for a part of the year, while the South Pole is tilted away from it. And for the remaining part of the year, the situation is reversed. This gives rise to changing seasons and opposite seasons in the two hemispheres. Now this will become even more clear when I explain to you the concept of solstice and equinox. The next effect, the tilted axis and the revolution of the Earth, they create heat zones.